All right, so I don't think a lot of you guys know this compound. This compound is called Taxol. Okay, so Taxol is one of the most powerful anti-cancer drug in our in the medicinal chemistry history. Like one of the most, not always. So we have a bunch of it, right? But it's one of the best one that we have. So and Taxol is actually a natural product, which means nature can synthesize it. Right, nature can make it. We use Taxol in in treatment of ovarian cancer, breast cancer, some type of lung cancer. So when there's a lot of people who smoke, like back in the 60s, 70s, people smoke like crazy. Uh, Breast cancer, ovary cancer, this is really happen quite pretty often. Like one of the 3 or 4 women have this type of cancer, which is really really sad. Okay, so Taxol is really really popular to treatment of this cancer. Uh, Taxol can be obtained by extracted from a bark of Texas. I don't know what it is, but it's U3, all right, from Pacific Northwest and Europe. So I'll give you a tour real quick. So Pacific Northwest is right here, and Southern Europe look like right here: Italy, Spain, Portugal, Turkey, right? So the U3. So I'm sure you have seen something like this, maybe in a movie, or maybe you go abroad. You probably have seen some type of U3 like that. All right. So, all right, taxonomy of this type of tree. So, is in the category of evergreen tree, always green. Okay, never change color. Size could be small, medium to large, and the age lasts super long, 400 to 600 years in average. Right, and they grow really, really slow. It takes time. We have this one, so 4,000 years old in Turkey. Okay, and 2,000 years old in Scotland. Right, but here's the thing, though. This type of tree is a slow growing tree, right? If you want to extract Taxol from it, well, we have to kill the tree. And this guy takes 200 years to grow. Not only that, the tree itself is a habitat of this type of, like a lot of animal, especially look at these owls. How could you look like a puppy? How could you destroy their home? I just can't imagine. People do, but well, people do. Human. Sorry, we are human, so we are mean. Anyway, so it's not really worth. I can't say not worth it. It save life. But it's just hard to combine, right? It takes years to grow the tree. So Taxol is really hard to make naturally, and we just kill the tree quickly, right? Let's say, and the way we kill trees, so we kill the tree first by take the bark of the tree, and we extract the compound Taxol from the bark of the tree, and of course we destroy the home of this animal and habitat. Okay. Now, so people will think, well, I mean, if nature takes too long to produce Taxol, can we make it in the lab? Well, Taxol is basically, look at the molecule. It looks just like the regular organic compound, just a bunch of functional group. Can we make it though? Okay, to make it, we call, okay, in academia, oh no, in a chemistry we call total synthesis. Make like a big molecule from small molecules, right? So there are 5 ways, 5 synthetic route to make Taxol. Some they make from camphor. I think you use it in the lab, in the OChem lab, and many schools use camphor to do either reduction reaction. Okay, that's camphor. Hold on. Alpha pinene. I'm not sure you know that, but it's one of the natural products. L-serine, which is amino acid, right? This one Mukayamas route. So this one proposed by a Japanese chemist. Mucic acid. I don't know what it is. Look like a sugar to me, a sugar chain. And we have this the 2 rings right here. Anyway, right? So there's a camphor. They said alpha pinene, look like that. Anyway, Robert Horton in 1993 from Florida State University proposed the way of making Taxol. Look at him. Look at how he make it. So there's a start with this compound 1, make. Or this is go backward. This is Taxol retrosynthesis. Go back there, here, and here. Okay. So look at his synthetic route. His total synthesis. Start with this compound. Step 1, step 2, step 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13. How many steps are there? 14, 15, 16, 17, 18, 19, 20. 20 steps now. Oh my God. 21, 22, 23, 4, 5, 6, 7, 8, 9, 10, 30 steps. Some of you might recognize osmium tetroxide, LDA in tosyl chloride. LDA is a base. DBU is a type of base, right? Pyridine right here, hydrofluoric acid. Alkyl lithium like phenyllithium. You probably have seen N-butyl lithium. We used that before. NMO right there. Third butoxide, potassium third butoxide. You've seen this is just organic Ochem 1 reagent, right? And no, keep going. So 31, 32, 33 steps, right? That's a lot of synthesis route to get to just Taxol. That's a Taxol route that right there. Okay. Now these are really difficult to make them. The longer steps are there, the less yield you have at the end. Okay. So they try to come up with a new way to mix Taxol. This is way too many steps now, and they found out that we call this way semi-synthetic drug, which means some part of the molecule are made by nature, and the rest we human modified later. So the English yield needles. So there's a tree right here. The needles actually make this compound, 10 the acetylbucatin. I don't know how to say it, right? But this can be can be used as a precursor of making Taxol. Look like that right there. Okay, and you can do 1 step, 2 step, 3 step, 4 step. You get to Taxol right at the 80% overall yield lab scale, not the industrial scale. But this way works, right? So this is from a really brilliant way of making Taxol and save tons of life by Florida State University faculty. Amazing. And the good thing is we can save a lot of life, right? And we don't have to kill the tree. And so this little owl can have the place called home. All right, so we finished chapter 19. I hope you learned something, quite a lot of things. So the rest gonna be practice, practice, and practice. Okay. All right, I'll see you guys on the next chapter.